Hello, everyone. Welcome to week 2 of Monday Minutes. This week, you're going to be viewing 2 lecture topics on our playlist on YouTube. The first is a lecture about biochemistry, and the second is a lecture about cell structure and function. In the topic concentration guide for the biochemistry material, one of the first things that you're asked to be able to do is define some very basic terms in chemistry, including element, atom, molecule, and macromolecule. You need to be able to name elements when you see them with their abbreviation from the periodic table, and you need to be able to read a chemical formula. In other words, know what different elements are in it, how many atoms of each, and whether or not there are any charges associated with the molecule that those atoms create. Now, in this course, you're not expected to know the names and symbols or abbreviations for all of the elements in the periodic table, only the ones that are most commonly encountered in living organisms, including those 4 key elements that we talk about in the lecture: oxygen, nitrogen, carbon, and hydrogen. Remember, if you took all of the biological material out of a human body and you analyzed the different elements that were in it, 96% of that material would be made of 4 elements: oxygen, nitrogen, carbon, and hydrogen. And that's why we learn as much as we can about these elements in a course like this. We need to understand the properties of these 4 elements in order to be able to predict how they're going to behave in a living thing. One of the things we focused on in the lecture is electronegativity. Remember that of these 4 elements, oxygen has the highest electronegativity, followed by nitrogen, followed by both carbon and hydrogen. Don't forget this, because this is going to show up again and again for us. Carbon and hydrogen have essentially the same electronegativity. That helps us predict how biological structures are going to behave when molecules within those structures are primarily carbon and hydrogen. Oxygen is higher in its electronegativity than nitrogen, and nitrogen is higher in its electronegativity than both carbon and hydrogen. Neither carbon nor hydrogen has a higher electronegativity than the other. Those 2 have the same low electronegativity. Now, we talk in the lecture about the fact that 96% of the biological mass in a living cell is made out of the 4 key elements: oxygen, nitrogen, carbon, and hydrogen. But of course, there are other elements inside living things as well. Some elements that we encounter more often than others. For example, sodium, chloride, potassium, and calcium are some of the individual elements that we're going to be talking about this semester. You'll notice that I have them written right here in their ionic form, because these particular elements tend to ionize in a watery world, a watery environment, which is what living material is. It's a watery environment. So we don't tend to see sodium chloride intact inside of a watery place. Instead, sodium chloride ionizes into sodium with a positive charge and chloride with a negative charge. Potassium has a positive charge. Calcium, which is another element we encounter quite a lot in biological systems, has a +2 charge on it. Remember what these charges mean. When we look at the atomic nucleus of an atom or a molecule, we expect the proton and electron number to be the same if that atom or molecule is neutral. When you start to see charges on atoms and molecules, it tells us that we don't have the same number of protons and electrons anymore. Sodium, for example, has an extra proton, or you could think of that as one less electrons. Chloride has an extra electron. Potassium has an extra proton, or one fewer electrons. And finally, calcium has two extra protons, or two fewer electrons. Remember, anytime we see a charged atom or a charged molecule, we can call that thing an ion. If it has a positive charge associated with it, it's a cation. If it has a negative charge associated with it, it's an anion. It doesn't matter how many extra protons or how many extra electrons an atom or a molecule has. If it has a charge associated with it, it's an ion. It's important as students of anatomy and physiology that we're able to read chemical formula. We're going to be seeing and hearing about different types of molecules that are involved in the physiological processes in the human body. Sometimes we'll see the name written out fully, and sometimes we'll see it as a formula. If you look at this formula that you can see on your screen, this is a molecule that's called calcium carbonate. You should be able to look at this formula and tell me what elements are in it and how many atoms of each element are there. For example, we have one calcium atom. That's the capital C lowercase a. We have one carbon atom in the center of the molecule. And then we have 3 oxygen atoms. Notice that this is a neutral molecule. There is no minus or plus in the superscript position next to the O3. When you see this number 3 in a subscript next to the O, it's telling you that there are 3 oxygen atoms in this molecule. When we see a charge on a molecule like this, it would be in the superscript position. Here's another formula that we see often when we're talking about anatomy and physiology. This formula describes a molecule called sodium bicarbonate. Technically speaking, this molecule is sodium, hydrogen, and carbonate, but its more common name is sodium bicarbonate. Sodium, that's the capital N's lowercase a. Hydrogen, that's the capital H. Carbon, that's the capital C. And once again, we have oxygen with a subscript, number 3 next to it. That's telling us that there are 3 oxygen atoms in this molecule. Take a look at this one. This is a completely made up molecule. It's got atoms in it that don't exist in the periodic table. There's something called XA, there's one called B, and there's one called M. I wanted to use fake elements here because I want you to be able to read a formula without recognizing what the molecule is. Now notice the way this molecule is written. There's one atom of this element called XA. There's one atom of this molecule called B. And then we've got this atom of this element M, followed by some numbers. Part of the problem with reading formula on a computer screen is that sometimes the numbers and the charges that are listed on molecules are not in the proper subscript or superscript format. This is very commonly encountered when you go online and you're looking at formula that have been typed out. The correct way to write the formula is to subscript in some places and superscript in others. There. Now the formula is written correctly. Whatever this pretend molecule is, we can now see more clearly that there are two atoms of the element called M, and this whole molecule has associated with it a -2 charge. That means that there are two extra electrons associated with this molecule. Here's one more for us to look at for practice. In anatomy and physiology, particularly when we talk about physiology, there is a functional group that is associated with a lot of different molecules, including the macromolecules. And that functional group is called a phosphate group. That's what you're looking at on your screen. This is a phosphate molecule written out in its chemical formula. The P here represents an atom of phosphorus. That's the element. It's combined with oxygen. That's the capital O. You'll notice that there's a subscript here of the number 4. That's telling me that while there's one phosphorus, there are 4 oxygen atoms in this molecule. Notice that this molecule is also charged. It has a charge of -3. That means that there are 3 extra electrons associated with this molecule or functional group. In a course like this one, we come from a lot of different backgrounds. Some of us have had chemistry quite recently, and we might feel very confident in our ability to describe different elements and different numbers of atoms and different amounts of charge associated with a molecule. For others of us, it may have been a while since we've taken chemistry, and maybe we've forgotten a little bit of that basic information. You should know that on the exam that's coming up in a couple of weeks, and later on during the semester on some other assessments, you will be expected to be able to look at a chemical formula and name the different elements that are present in that formula, as well as how many atoms of each element there are, and whether or not it has a charge associated with it, and what that charge means. If you need a little extra practice, remember you can get some practice using examples from your textbook and also online. There's one more thing I want to show you on our Canvas page. If you go to the home page and then click on the link that says discussions, remember it will take you to our 3 discussion boards. The first board is where you were asked to post an introduction about yourself. The second board is about questions associated with lecture, if you ever have any of those. And finally, there's a board where people can post interesting stories about anatomy and physiology in the news. Go ahead and click on the board that says questions about lecture. You'll notice that I posted on this board today. I'm just going to read the post that I made. In each of the lecture exams that you'll take in this course, you'll be asked to write short essays about the concepts we're learning. Most exams will have 2 short essay questions worth 10 points each, and 1 longer question worth 15 points. These essay questions are designed to test whether you can apply the things that you're learning and combine concepts. The very best way to practice these essay questions is to practice these essay questions. In other words, try writing out short essays. So each week I'm going to post a question or 2, and I'm going to ask you to write out a short essay, how you would answer it. So here's one I want you to try this week. In a paragraph, explain why anatomy and physiology are always connected to each other. All you have to do is hit this reply button and type in your answer, just like you would type it in if you were taking an exam. I'll be looking at what you write as your short essay and giving you some comments on it to help you improve. Okay, everyone, that's it for today's Monday Minutes. I hope you enjoy the rest of the day. Stay safe. The roads are pretty bad out there. Remember, if you have any questions about any of this week's material or anything else related to the course, please send me a message through Canvas. I'll talk to you again soon.